Bachelor.
It's 8,
I'm
just so you know.
Calm down.
Yeah, so anyways, I have no tricks anymore out my sleeve because everybody uses slide caramel now. So you're welcome, everyone.
I haven't used it yet, but I intend to, no?
I hate verifications.
If you're watching this in the future, 2-step verification stinks. BGS use 2-step verification? Even worse.
Yeah, especially when you get a new phone and you can't even do the duo push anymore.
Plotting the Pythagorean.
You guys are the worst.
They're on every slide too.
Yeah, actually, we're the best. So, today,
I started this!
today what Jack and I are going to wind up going over is applications of the Pythagorean theorem. But first,
I'm so bad.
Kahoot, go ahead and tap on that link. Jack, tap on the link.
Boom.
Oh, man.
Another login. Log in, no. I was gonna say if you log in with your Google, just do that. Just log in with your Google. Unless, yeah.
Unless it's with a completely different.
Well, if it's your Gmail, it should be the same password.
Stop. Oh my god.
What is happening?
Oh.
Students, I apologize.
Go to Kahoot. There we go.
Boom.
There.
Alright, guys.
Ka-chow.
Try some of that.
From teaching children
So-
with sensibilities.
Go ahead and go to kahoot.it. Next, what you're going to do is you're going to type in that game code, and then we are going to pick appropriate usernames.
And disregard the 666.
Oh no.
Now, you'll want to have a pencil and paper ready. Well, maybe a calculator as well. There are a few solving problems that we'll be going through.
Problems or exercises? Just asking for
Exercises. And this just kind of reviews what we've covered over the last couple of days.
Yeah, like days prior to this. Because our lesson's 3 out of 5.
You're pretty good.
Oh, my phone.
Good job, guys.
Amazing.
Well done. Well done. Noah with the quick fingers.
Hey, Jack, can you scoot over a little bit?
Well done. Well done.
Sure.
Well played. Well played. Ooh, better than Josh is doing worse.
Doing worse.
Oh my.
I'm guessing. I'm just guessing. I don't have a calculator, so.
Hey,
Use
see
your
me after
phone.
class, and I'll see what I can do about providing you with one. Okay.
Try.
Okay, you should be able to get this one. I would hope.
Alrighty.
Did it
This is the
Because
last.
it's too
Well, actually, we have 2 more after this. I apologize.
It literally says it was out 6 of 8.
I didn't see the numbers up there until afterwards.
That looks like it's about 11. It was about 11, to be fair. it's more than 24, so there's only 2 options.
When making the Kahoot, I accidentally marked every question as right on accident. The first time through, and then I said, oh, that's what the check mark's for. Alright, here's the last one. Question 8 of 8, for those of us that were wondering.
Yeah.
Centimeters.
All 3 of us put 17 and not 17 centimeters. Wow.
Well played. Well played. So, essentially what we wanted to go over here is that when we are talking about right triangles, we're going to refer to the vertical and horizontal sides
You rate those
as
as
legs,
1.
and then the large diagonal is the hypotenuse. Also, while the formula is a squared plus b squared equals c squared, you may see these side lengths represented by different variables. Any letter, A through Z, perhaps some letters from the Greek alphabet, such as alpha, beta, gamma, delta, epsilon, anything like that. Also, we need to make sure that we're paying attention to our units. That's very important when we're dealing with some of the different problems and tasks that we're going to be taking a look at today.
Attentive precision.
Indeed.
Really got us with that last question.
Yeah. I jumped to conclusions.
So, we're going to give you guys this paper. And what we want you guys to start thinking of and talking about is, what are some distances that you travel every day?
I walk to my car and from my car.
Then where do you go when you get in the car?
One of 3 places. Campus, Grounds for Thought, Nagoya, Perrysburg.
Yeah, right.
Travel from
I
campus to
go
grounds.
from my dorm to math sci.
Math science.
Math sci.
Math science.
Math side. Caitlin, where do you go?
I go from my apartment to the bus stop.
To the bus stop. And once on the bus, where do you go? What's your destination?
Centrix building.
Centrix building.
What is that?
That's the one by the Ed Building in University Hall.
Yeah.
It was closed our freshman year.
Oh, okay. It's
Yeah,
that.
it's where the
Okay,
shuttles
yeah.
go.
It's where all that construction is.
Now, you have a distance that you travel. We want you guys to think of the lateral distance. So if we're talking east to west, where do you start and then where do you end up? Do you travel a certain number of yards or miles east or a certain number of yards or miles west to get to your destination? So like if, Caitlin, you're at your house and then you're going to the Centrex building, where is it in relation to each other, left to right? And so we want you guys to go ahead
I'm
and
looking at a map.
write that down. If you need to pull up a map, feel free.
I don't know exactly how many miles Grounds for Thought is from my house.
Yeah.
And you guys can use any units you want. Just make sure that you use these same units every time.
Let's be clear that we're not using kilometers.
Fair enough.
Okay, but like I don't go like straight there. I gotta like turn on some streets and.
That's correct. But we want you guys to think of it as if you were going
Just straight.
all the way to the
Yeah.
right. Don't think about like going down yet. Think only a horizontal shift.
I don't know.
It doesn't have to be
Oh, so
exact.
you can-
yeah, you can
like,
estimate it,
Yeah,
in
it
all
doesn't have to
honesty.
be like 5.21.
We just want to make sure that you guys are using a distance that's relevant to you.
Okay, it's about a mile.
About a mile? Okay. So go ahead and mark that down. And then after we've figured that out, I would like for us to think of the vertical distance. So let's say I live on 7th Street and I'm coming to Wooster Street. How far up did I have to go? So for your guys' distances that we wrote down, north, south, roughly how far do you travel?
Also about a mile.
Wonderful.
Where are we plotting these, or like where are we?
You can make it out.
You guys can just write out the distances. I believe they correspond with some of the first couple of questions.
And then if you want, you can make like a sketch of like what you think it would look like on the back of this worksheet.
Correct.
I hope not all of your guys' are one.
I'm talking about the distances we travel here. It's probably all pretty close.
Oh yeah, it's probably like traveling from my apartment to campus is probably not even a half a mile.
Yeah.
But do I still drive? Yeah.
Do I still drive? Yes.
I like the representation. And then once we've completed marking down our horizontal and vertical distances, what is the shortest possible distance that you could travel to get from your location to your destination?
1 mile.
Wonderful. Now, Noah, since you already have your answer, how did you go about solving for that?
I use Google Maps. It told me the shortest distance. No, I'm kidding. It makes a triangle,
What kind of triangle?
a right triangle,
Oh, that's pretty cool, isn't
where
it?
you can use Pythagorean theorem. 1 squared plus 1 squared is 1 squared.
Okay. Now, do we feel like we could use
Is it
that?
square
Wait,
root of
it's
1?
It's a square root of one square root.
Right, it is square root
It's
of 2.
one
Oh my god, it's not a mile. I can't do math in my head, clearly.
That'll happen. PEMDAS trips me up a decent number of times. You can write an approximation if you want.
Or just put square root of 2.
That also
Oh,
works.
no.
See like a 10 of precision with Filipova. I want exact answers.
Be sure to use complete sentences. Whenever you guys have that shortest possible distance, go ahead and just set your pencils down. That way I know when it's okay to move forward.
Just kidding, it's 1.4.
1.4. Wonderful.
It's nuts.
Alright. So. Go ahead.
Alright, so I travel to school every day by going 500 yards north on Enterprise Street and then 100 yards east on Ridge Street. What is the shortest possible distance that I can travel to get to campus? So you guys can set this up by diagram or just an equation, anything you'd want. Any way you feel comfortable representing this problem.
I cannot draw a straight line.
And then when you guys are done, set your pencils down, and then we can compare answers. Seems like everybody got the same answer of 509.95, isn't it?
So the next question we want to ask you guys is, why is it important to be able to know like the shortest possible distance you need to travel? Like, what's the use of a shortest possible distance?
What's it do for you?
Save time.
Saves you time. Okay, I like that. Any other thoughts?
Did you gas?
Saves you gas. So knowing that shortest possible distance helps you out financially as well as with your time. And so whenever we're traveling anywhere, being able to find that shortest possible distance that we could travel is very helpful. What a lot of our different mapping softwares use, when you take a look at it, is they try and keep you as close to what the hypotenuse of the right triangle involving the vertical and lateral distances would be. Of course, with streets and everything, you have to turn left and right, or you're going down the curves of the highway, so it's never a perfect line, but they always try and choose the shortest possible distance, and that winds up saving you time and money. So now that we know the importance of the shortest possible distance, what we're going to do is you're going to use the football field on your page, and what we want you guys to do is pick a number between 0 and 50. Noah, what's your number?
24.
24? Okay. Go ahead and mark your position on the 24-yard line on the left half of the page. Julia, 0 to 50.
17.
17? Okay. And Caitlin?
27.
27? Awesome. So now that you guys know your yard lines, go ahead and pick a number between 0 and 54.
0 and 54?
Yes.
Because usually this,
The 54.
it's the width, 54 is the width of a football field. It's actually 53 but no third, but you know, to
We were
make
just
it more
rounded up.
applicable.
And you're going to assume that there's 18 yards between the sideline and the first hash, 18 yards between the first hash and the second hash, and 18 yards between the second hash and the sideline. Sideline to hash.
You're telling me that that middle distance is the same as those two side distances?
In a high school football field, it's more close to being the exact same.
Yeah.
We're just going ahead and defining the distances for you to make it a little easier to plot your position on the field.
Because this is like a NFL hash.
So I'm picking a number between 1 and 54.
Between 1 and 54, correct.
What if I pick 54?
What if you pick 54? Then you pick 24 as well, right?
Yeah.
You may find yourself right around here.
So I'm like
Down on the south
same,
side.
like left side.
Correct, you're staying on the left
What if
side.
I'm counting up? Then wouldn't I put 54 at the top?
Well, would you guys like to count up, top to bottom, or bottom to top?
Yeah, whatever preference you have.
So like 0, 18.
Yeah.
Okay.
Yeah, that was the way I
Okay.
thought of it.
Then go ahead and plot your position on the field.
At the 24-yard line. Also. Right?
Correct, yeah.
Okay.
Keep the yard line that you already had, and then just plot your vertical position
Yes.
on that yard line.
18. I thought the same
Did
thing.
I get to keep like? Do I? Okay, the first point, did I get to put it anywhere I wanted on the 24-yard line or no?
We were having you pick the yard line by just picking a number 0 to 50, and then we were having you pick the distance from one of the sidelines 0 to 54, so that way you could plot your point. So it's okay that you have it's okay if you have a point marked on that yard line, just to make sure you knew where you were horizontally in relation to the field. But you only need this final point that has your horizontal and vertical position.
So this one.
Correct.
Okay.
So, imagine this. You are playing for the Bowling Green State University Falcon football team. You and your team are making an offensive drive, but your quarterback throws an interception. And this is the man that caught the ball. If Dr. Bray is on the opposing 20-yard line, 5 yards south of the north sideline, what is the shortest possible distance that you can take to tackle him, assuming he catches the ball and stands still? We're going to give you guys several minutes to figure that out. Be sure to mention the vertical and horizontal distances, because we want to try and take a look at how those might impact how far you have to go to tackle.
And what's the point that he's at again?
He is at 25. So 20
25.
yards from the right end of the field and 5 yards from the top.
So
Thank you.
whichever preference would you guys rather
I think they count bottom to top.
would you guys rather measure with the ruler or do yardage?
Yardage
For-
is fine.
Yardage, okay, for distances away.
Yo,
One at a time.
that was
Okay.
fast.
That's cool. What we can do, guys, is if you want to pack it up, we will have you guys wind up calculating these distances as homework, and then we will collect that tomorrow and get back to discussing in class. Thank you.
But not really, like you.
Please hit the stop recording button.